Hello, in previous episode we saw the problem by having a synchronized method where multiple threads are trying to compete with each other. It's okay to compete for the creation and to wait, but it's not okay if the object is already created and you want to have that reference to have that object second time or third time or even fourth time. So there should be no competition at that point. Let me explain to you how this will work. So let's say there are two threads which are concurrently trying to get into or trying to get the instance. They both will check if the instance is null. Yes, instance is null. They both will come here, and then only one will enter and one thread will wait here. So the first thread which checks like, okay, this instance is null, it will create the object and then it will return. Simple, straightforward. Now the second thread which is waiting here will also enter this condition, and it will see that the instance is already created. So it will just simply leave this if condition and go straight here and return the instance. That's it. That's the pretty straightforward logic. Now let's say the object is created. Now 100 threads concurrently try to get the instance. All of them will reach here. They will check, okay, instance is not null. They all concurrently can go here and just return the instance. Now we are not locking. We are only locking for the creation part. If threads are competing to create the instance, then okay, it makes sense, it should be locked. But after that, whenever any thread need to get the instance, there will be no locking at all, and it will be performance solution and it will work very well. So let's run the code and see if we get the result we are looking for. Yes, we are actually getting the correct result. But here there is an important concept, which is when the threads that tries to run a method, they create a cache and where they put the variables, and maybe when one thread is creating the instance of the object of the class, this creation or this change may not have been published to the rest of the thread, because every thread is carrying their own cache, so they might not see it. And for that, Java has a keyword, like we can use volatile for that. Actually, let me show here. Here it is suggesting that it is double checked locking. It already has detected, so it says make the instance volatile, and we can see here our instance is not volatile. Volatile means to instruct the thread not to read it from your cache, but always read or write to directly into the main memory. So once it is changed in the memory, all the thread will immediately see the change. So that's how we communicate the change across the threads, because whenever multiple thread runs, they create a cache and they put things in their own cache, and once their execution is done, then they publish it. So we don't want to do this. We want to make direct changes to the main memory, and that's why we are using the volatile. This is another important concept which is in Java, and you just got to know because of the Singleton pattern. So that's it. Now our class is thread safe, it is performant, it is the perfect way to write a singleton class which is lazily loaded. Now in the next episode, we will try to create a singleton with the help of enum. Thank you, take care, bye.